One of the most fundamental aspects of geology is the conditions that are required to accumulate sediment. When I look out at the spectacular view behind me, I see layered rocks. Beneath us, above the Green River, the white rim sandstone, up into Triassic, Chinle and Moenkopi, on up to the Wingate. And you can see clearly these are layered deposits of sediment. How do we create a layered deposit of sediment? The first thing that is required is for the land surface to sink. So I want to talk about the processes that create subsidence. Imagine the Earth as a water balloon. I think that a water balloon has about the consistency and texture and feel that the Earth has if you consider it at the scale of a planet over geologic time. When I've got a water balloon, if I push my finger on it, I can push it in and deform the surface of the Earth and make a hole around my finger. In the same way, when we build mountains, like the distant Henry Mountains out there, snow-capped on the horizon, those mountains are a physical weight, and they push down on the surface of the Earth and cause it to depress. Going back to the water balloon, instead of pushing my finger on it, I can stretch the surface. I could grab it in 2 points and pull it apart. And when you stretch a rubber band, it gets thinner. And if we stretch the surface of the Earth, it gets thinner and it will actually sink. The third thing that we could do would be to chill the balloon. And if we reduce the temperature, the water inside contracts and the outer surface of the balloon moves in towards the center. The same three processes affect geology and the Earth. We can load the crust, we can stretch the crust, and we can cool the crust. And those three processes create depressions on the surface. When we have a hole or a depression and the land surface is moving down towards the center, it can accumulate the durable part of landscapes. When we go somewhere like the Texas Gulf Coast, we find rivers. The rivers carry mud and sand, and that mud and sand is left as a layer filling in the hole. In a future time frame, sand dunes might blow across, and those sand dunes will sit on top of the old river deposits. In the view in front of us, the rivers deposited the lower part of this fill, and then to either side we see larger cliffs up at the elevation where I'm standing, and those larger cliffs are a sand dune that built out across a river valley. Because the land is sinking, everything that doesn't blow away or get eaten or decompose, like trees decomposing by bacteria, becomes part of the geologic record. Subsidence is a fundamental process that allows us to preserve sedimentary rock. But something else has happened in this landscape, because we're looking at mesas, flat plateaus, and cliff faces, and it's a topographic hole. There's a depression in front of me, and there's a river down in the bottom of it. So it's obvious that today, these rocks are not being deposited, but they're being eroded and removed. Today, we're at an elevation of approximately 5,000 feet above sea level. After the land sank and accumulated the rocks, the land has risen. Well, why might it rise? Just like I can push on the outside of a balloon, imagine if I'm inside the water balloon. I could push from inside the balloon and raise its surface. I could actually take a rubber band and imagine squeezing it together instead of pulling it apart, and it would get thicker. Or I could heat the balloon, and that would cause the surface to move away from the center. So contraction or thickening of the crust and heating and putting a load underneath that pushes up cause the land to rise. This land first sank and accumulated a basin full of layers of rock, and then the process changed and it was lifted up into the sky, and the river that we see before us is in the process of cutting and removing that sediment. The landscape results from the river cutting vertical cliffs in strong material and leaving plains and plateaus in the weak